Let's continue looking at proofs, looking at proof F. On proof F, you start with a pair of parallel lines, and your goal is to end with a pair of parallel lines. I'm going to add some notation. This should have a bar over the top of it there. So keep in mind that when you have a pair of parallel lines, you're going to get angles from them. The angles you get from those parallel lines must touch the parallel lines as well as the transversal. So let's go look at what angles we're going to get from our given parallel lines. We've got UT and RS. So if we go find UT and RS, and if we find the transversal that connects them, you want to follow the pink lines. These will outline the two angles you're going to get. From these parallel lines, we are able to get angle 3 and angle 2, but those are the only angles we will get from the parallel lines. We also had another pair of given angles of U and R. So I'm going to give them a double mark since I already used a single mark. Now, to get a pair of parallel lines, we would need a pair of angles in order to prove the lines are parallel. So if we would like to get US and TR, then we're going to need to know that angle 1 and angle 4 are congruent. Now there's two versions of this proof. I'm going to do the one that is probably going to be most people's method first. And then I'm going to show you the alternate method that is possible. And some of you might already see it right now and wonder why I'm going to do the method I'm about to do. All right, so we've got our given. So let's put our given into the proof. And we had U and R. Given, there we go. We mark that in the picture, and these two triangles, because this unit is all about congruent triangles, are they're touching triangles and they share a side. They share the side ST. My alternate method I'm going to do after doesn't use the triangles at all. Well, not congruent triangles anyways. And that was a congruent sign, so reflexive property of congruence. This allows me to get the two triangles congruent by angle side. So we can say triangle UTS is congruent to triangle RST by angle side congruence. Now that the triangles are congruent, you can talk about their corresponding parts that you didn't already have. We're going to use CPCTC because we have already proven some triangles congruent, and I want to mention the three parts that we can talk about now if we would like to. The parts that we did not originally have that we could now talk about, we could say UT is congruent to SR. We could say US is congruent to TR. Or we could say that 1 is congruent to 4. In order to get parallel lines, I am going to need to use the angle pair 1 and 4. So I'm going to go ahead and I'm going to say 1 is congruent to 4 by CPCTC. And then this allows me to get my parallel lines at the end. Remember that when you're going from parallel lines to angles, which I just realized, I didn't put that angle pair in the proof. So I need to scoot my triangle. Happens to us all. Let's scoot that down. I forgot to talk about 2 and 3 in the proof. So I need to scoot those before the triangle pair. Remember, it takes 3 things to prove triangles congruent. And as I can see, I had this angle and I had this side, but if I want to use AAS, then I'm missing the other angle. So I better make sure that I go back and I add that angle in there. Angle 2 congruent to angle 3. You should always check that you have that in your proof before you say your triangles are congruent. Since I'm using the parallel lines to get that angle pair, I'm using one of our theorems. 2 and 3 are alternate interior angles, so I'm using the alternate interior angles theorem, and you could say that for the reason, or you could say if parallel, then alternate interior angles congruent. which is the order that the theorem goes in. Now, when you are using angles to get to lines, you need to use the converse. And 1 and 4 happen to also be alternate interior angles, so I'm using the alternate interior angles converse, which you could write that for the title, or you could say if alternate interior angles congruent, then lines parallel. So that would be the normal method for people to do proof F here. The alternate method for this would be to use angle U and R from the given, angle 2 and 3 using that if parallel then alternate interior angles congruent. So if you used your given and you used the third line here, from there you could find out that angle 1 and 4 are congruent by the third angles theorem. And then you can go straight to your parallel lines. So instead of CPCTC on this line, you would say third angles theorem, and then you could go to the fourth line. So it would cut 2 lines out of the proof if you wanted to do that method. And so just an idea if you saw that, or if you like the third angles theorem, like I do. I just love that there's alternate ways to do the proofs. Proof G. This one has multiple methods as well. If you look at your given, the first thing you're given is AD congruent to DC. This makes this an isosceles triangle and could get you angle A congruent to angle C with the isosceles triangle theorem. And you could use that if you would like to, if it helps you. Other things that we have that DB bisects AC. When you have a vocabulary word and you're given, you're going to be using the definition of that word to gain information into the proof. Like bisector means splits in half. Whatever is next to the word bisector is the thing that is being bisected. And so bisecting a segment, that creates 2 congruent segments. If you're bisecting an angle, it creates 2 congruent angles. If AC is bisected by DB, that means that AB is equal to BC. We also have touching triangles. These triangles are touching in a way that they share the side in the middle, side DB. So it's very easy to prove these triangles congruent through side, side, side. If my goal is to get an angle bisector, as you see here, then I need to find the angles that would be equal from that bisector. And then our sub goal before we're able to end the proof would be to find out that angle pair. If DB is bisecting ADC, then they are going to be using 3 and 4 to prove that this is a bisector. So I would like to use my 2 triangles here in order to say that 3 is congruent to 4, in order to get the fact that DB is a bisector of angle ADC. So here we go. We've got our given. We're going to use that bisector right away since it's right there, so we don't forget. AB and BC, definition, bisector. Remember, just really important, you need to know if it's an angle bisector or a segment bisector and how to use that. I've had lots of students using the angle bisector incorrectly lately. Then we have 2 sides right now. We need our third pair of sides, which is DB congruent to DB by side, side, side. Now we're able to get the triangles congruent. So ADB congruent to CDB. The first one I just named however, and the second one I had to make sure, whoops, side, side, side is for the triangles. DB congruent to DB was reflexive. Property of congruence. There we go. Now that's fixed. All right, so our triangles are by side congruence. Remember that when you're naming the first one, you name however the second one, you have to match how you named that first one. And now we need to think about our goal. Our goal is to get an angle bisector at vertex D up there at the top. And so if the angle at D is bisected, that would mean that 3 and 4 would be congruent to each other. So if I'm able to say that 3 is congruent to 4, then I would be able to say that I have an angle bisector there. So keep in mind again, once your triangles are congruent, you can use CP/CTC to get any corresponding part of those triangles that you don't currently have. The parts I'm allowed to get right now are angle A congruent to C, angle 1 congruent to 2, or angle 3 congruent to 4. Those are the pieces I did not originally have, and now that the triangles are congruent, we could use them. So I'm going to now state that angle 3 is congruent to angle 4 by CP/CTC, and that proves that we have a bisector. It proves that DB is bisecting angle ADC by the definition of an angle bisector. And that takes care of all of our proofs.